This is Edmund. This is my video for the AVL-tree double rotation. So the question that I took was question 9, where we have the array 5, 10, 3, 1, 7, 12, 8, 13, and we're adding the value of 7.5 as the extra nodes. So here we're just going to add 7.5. Greater than 5, we start at the parent node, less than 10, greater than 7, less than 8, so we should see that it appears here. This diagram here is just to show that the 7.5 appears to the left of the node 8. Checking the balancing of the tree, we can see that 7.5, 11, 13, and 1 are all balanced. We start from the left. The node at number 3, the right child is 0, but the left child is 1. So it'll be 1 plus 1, which is 2, but it's balanced to the left. Let's have a look at this side here. The node at 12, both childs are balanced, so this is balanced. It'll be 1 plus the highest value, which is 1 here, so that'll be 2. Having a look at the 7.5, the node at number 8, nothing on the right, but heavier on the left. So it'll be 1 plus 1, the heavier value, rather than the 1. So this will be 2, but balanced to the left, or tilted to the left. Looking at node 7, nothing on the left, heavy on the right. This would be 1 plus the highest value, which is 2, so that would be 3, and balanced to the right. Looking at this value here, this would be 1 plus the highest value, which is 3, so this would be 4, and it's balanced on the right. And here we can immediately see as well, the right tree of 5 is 4, the left tree is 2. There's a difference of 2. This will be 5, so we know that this is not balanced. So I've skipped the video a little bit just to add some balance markers into my code. So the top tree here is the original tree before we added the 7.5 node, and you can see the balance markers here, and this is what happens afterwards. And just to prove that the AVL insert pickup code works and rebalances the nodes, we'll have a quick look at what happens when we added the 7.5. So as we can see here, when we add 7.5, we check if the parent is null. In this case, the parent, let me write here, parent, just go per box, and I'll put cur here, and we'll change it each time. So the current parent is 8 for this one, and the current node is 7.5. If we have a look, bool from right is equal to parent.right is equal to cur. So is the right of 8 equal to cur? It is not. So we ignore the first part. If not from right, so it's false. Is the parent tilt right? The parent tilt is actually balanced. So we ignore the first part as well. And then we check if the parent tilt is balanced. We check is from right true, which is not. So therefore, the parent tilt will now be left, which is correct. Next, we change the parent to be 7, and the current value to be 8. And we have a look here again. Bool from right equals parent right equals current. The right of 7 is 8, which is current. So this time from, actually let me do this, from right is equal to true now, so that's good. So we check if true and the parent tilt is equal to the left. If we look at the original, the parent tilt is equal to the right, so that's false. And then we go down, so is the parent tilt right? Yes, the parent tilt was right. Is the current tilt, which is 8, right? This case is no. So that means it's left, it can't be balanced. And this is where we're going to be doing the first rotation. Just to mention quickly before I go, so here we have to set the AVL nodes A, C, and B, as we saw in the lectures. Let me just write here as well, maybe use different color. So A will be the parent, which will be 7. I'll put C at the bottom here. C is going to be the parent dot right, which will be 8, and B will be the current nodes left. Current node again was 8, so left of that is 7.5. So just going on to the next bit here, I've moved on to a new image of our binary search tree. So now we know what the nodes are that we're going to start rotating on. We need to perform the rotation. So what we're going to do is a left-right rotation, where we're going to rotate the nodes A, C, and B, or values 7, 8, 7, 5. We're going to rotate it to the left first of all, and then we're going to rotate it to the right. So we're going to rotate it left first of all, and sorry, let me just change this. Oops, took off too much. And then afterwards we're going to rotate it to the right. So what we do is, in the code, what's going to happen is, so the position of A is going to stay the same, but we're just going to change things up so that 7 points to 7.5, and then the right child of 7 points to 7.5, and then the right child of 7.5 points to 8, which would be the child of A. So A child would point to B, and then the B child would point to C. So on the left, this is the right-left rotation, but what we would have in the code, if it was pseudocode, would be AVL node B would equal to A dot right, assuming it exists, and then AVL node C would equal to B dot right, assuming it exists. And that would help us rotate this to the left to show this tree now. And then once we've done that, we perform the second rotation where we make it go to the right. And this time we're going to make it so that the left child of 10 points to 7.5. 7.5's left child would point to 7, and we would keep the right child of 7.5 to point to 8. And again, with the pseudocode that we would have, we would make it so that, let me put in what the nodes are again. So 7 is A, B is, so if this was node A again, oops, not that one. So if this was node A, that's node C, this is node B. I've got it confused. Okay, sorry, the other way around. This is node C, this is node B. Then on the second rotation, we'll make it so that the B dot left is equal to A, and B dot right would remain as with C for the final rotation that we do. And at that point, we would have fixed our tree so that it would look like this with 5 at the top. And now if we check the balancing now, we can see immediately that these are all just the non-child heaps that we have, all balanced at 1. If I use a pen now. So we look at 75, has both left and right tree, they're balanced. So this would just be 2. 1 plus 1, the maximum. Same with this one, 1 plus 1 maximum, and that's balanced. This one at the top would be 1 plus the maximum here, which is 3. Both left and right child trees are fine, so that's balanced as well. And hasn't changed on the left tree of 5. So this node node value 3 would be 1 plus 1, which is 2. Is left heavy, so this would be left. And this one now would be 1 plus the maximum value, which is 4, which is fine. And maybe right heavy, but yeah, at least it's more balanced now. And that's quick run through of the double rotation.